Slinging words you might remember from last year. Constant of proportionality, proportional relationships, the COP, the COP, the constant of variation, direct variation. Anyway.
You didn't let us call it COP
So,
because then you won't remember what it stands for.
Yeah. Lots of things that went on last year that we're going to pull on this year. So today is going to be like peer review, but then starting tomorrow, we're going to use this base knowledge to expand into a whole unit, multiple weeks, on lines. So we've already done lines with functions a little bit, but we're going to deep dive into lines, okay?
I hate lines.
Line. Okay?
Oh, you ate line.
So, again, I'm going to prompt us to consider learning these, and I'll go slow with certain things. We want concept. Because with lines, there's lots of stuff you do. And sometimes when in math, there's stuff that you do, you figure out how to do it, but you don't understand why, right? Anybody ever been there? Because I was there. 8th grade algebra all year, okay? Then when I took advanced algebra, the teacher's like, remember lines? And I was like, well, I remember I did stuff and got A's, but I don't remember why anything worked. Because I never learned why it worked. We learned how to do stuff. I want you to know why. So, we're at a jump-off point from proportional relationships last year. So, a proportional relationship is one quantity directly changes with another. So directly changes. And to kind of make this pop, we're going to look at an example next to a non-example of proportional relationships. Now these are both going to be lines. So line can be proportional and it can be non-proportional. We're going to look at that difference right now. So we're talking stars and Starbucks and free drinks. Okay? I actually think it's 50 stars to get a free drink now. Maybe inflation. Starbucks stars had inflation. I don't know. But, okay? We're going to start with a table, and I'm going to say the number of free drinks depends on the number of stars. Would you agree with that for dependent, independent? Yes, so the number of free drinks depends on the number of stars. Okay? So every time you earn 10 stars, you earn 1 free drink. So 10 stars is 1 free drink. Now, what would 20 stars be?
2.
And 30 stars?
3.
And 40 stars?
4.
If you had 100 stars,
10.
10 free drinks, your hands be shaking, you'd probably be sweating. I don't know what would happen with 10 Starbucks drinks. With the way that kids do it, they get milkshakes that they call coffee. You'd probably have something going on with sugar that you shouldn't. They'd be out of control, okay? So, here is my situation. Now, let's look at the graph. So, along my x, I'm going to have stars. And let's go 10, 20, 30, 40. I'm just skipping to give some space there. And then along the x, I'm going to have number of free drinks. So I'm going to 1, 2, 3, 4. So you kind of, you get to pick your scale. Drinks. Okay? So you need to make sure you label your x and y axis because math is communication. Those are telling us what's what. Okay? So 10 stars pumps out 1 drink. 20 stars pumps out 2 drinks. 30 stars, 3 drinks. 40 stars, 4 drinks. Okay? And this is kind of sort of a continuous, right? There's not partial drinks and stuff, but there are partial points, right? I think you can have like 18 points and you don't have enough for 2 drinks yet, but you have enough for 1. So just to see the trend, I did the arrow for it.
Is every drink a point?
I think it's like it's different now, but every something you spend is points. I don't know.
Also, how could you have inflation on something that's... It also is every time you order.
Yeah.
It's like 20. Well, no, you just
Okay.
like the stars.
So let's look at the non-example and then compare the two, okay? So for the non-example, we're talking Planet Fitness, all right? And for Planet Fitness, you pay $25 to join, and then $10 each month. So 1 month would cost how much?
$35.
35. So 2 months would cost how much?
$10.
45.
45 total. So we're talking cumulative cost.
Yeah, okay.
3 would be
55.
55, and 4 would be
65.
So here's a question. What's the common difference month to month for both of these? Well, not month to month, but the same common difference by 10, right? 10, 10, 10, 10, 10. But let's check out this graph. Along the x, I'm going to have months. Along the y, I'm going to have cost. All right, and I'm going to go every other with the months just to spread things out a little bit, okay? And then cost, I'll probably go by tens. 20, 40, 60, 80. All right. So at 1 month it's 35, right?
Hold on.
Wait, something's wrong about
2 months is 45.
Oh, it says 20.
3 months is 55. 4 months is 65. Now, how much would 0 months be? That might be helpful.
$0. So
25.
$25,
Oh,
right?
yeah.
Because you got to sign up. I don't know, paperwork or something, you know? Okay, so this is how this one looks. Man, I'm drawing some nice lines with arrows today. Anyway, what I want to look at is, what do you notice and wonder? What's the same and what's different about our two graphs here? One's proportional, the example's proportional, the other one is non-proportional. What do you notice, Tanya?
Well, the second one, it's not proportional because it doesn't go through the point of origin.
So it doesn't go through the origin, which is true. That tells us visually it's not proportional. Who can tell me how we know it's not proportional by the numbers?
Because you have to
Well,
add
There's not a scale factor.
yeah, there's not a scale factor, there's not a constant of proportionality. So let's look at it like this. No matter how many stars you have, the number of drinks per stars is 1 to 10, right? 2 to 20 is 1 to 10, right? 4 to 40 is 1 to 10. Now, looking at our price per month, 1 month cost how much per month? For Planet Fitness, 1 month cost how much per month?
The month is
For 1 month, it's $35 per month. At 2 months, how much is it per month, though?
45.
Not per month.
$10.
No?
It's 45.
For 2 months, it'd be $22.50 a month. The total price at 2 months is $45, right? Which means per month would be $22.50.
But it's not.
Okay, if you look at 3 months, it'd be like 18 something.
But it's not.
If you look at 4 months, it'd be like 16
Wait, but
something.
it's not.
So why is the price per month changing?
Hold up, I'm confused because it's not.
Because there's a base price.
Because we're starting with that extra $25,
It says
and the more months you go, what's happening to your $25?
The higher. You're just adding time.
It's spreading out, right? You're like spreading out that initial fee. So like, if you went there for 2 years, that'd just be like $1 per month of initial fee, right?
But it's not, right?
But it is, right? So if you talk the price per month, right? The price per each month is not constant. There's not a constant of proportionality. Now, there is a constant rate of change,
Which is 10.
which is $10 per month, but the price per month is always changing because your $25 is getting split up. So another way to think of it is maybe you've had one of these birthday parties at some fun place, and it's like $100 to reserve the room and then $15 per person.
Yeah.
Well, if you only show up yourself, it's $115. That's $150 bucks per person. But if you you fill the room, your price per person is less because that $100 gets split up among everybody, right? Okay. So that's kind of what that means. So they're both lines. They both have a constant rate of change, which we'll talk about more next class. But only one of these is proportional. It's the Starbucks one. So let's get the words to match what we're saying. That means a proportional relationship can be represented in the form of this equation. Y equals kx. You might also see y equals dx for direct variation. K or d in this case is the constant of proportionality. So if you're thinking up to our Starbucks, right? Y equals, it'd be 1/10 x. So 1/10 of the points would give you, for every 10 points, 1 drink, right? Y to x. If you're thinking about, well, we can't do it great for the other one. I can give you the equation for the other one if you want. It's 10x plus 25, but this is not proportional. So the graph of the proportional, you already said this must have 2 criteria. it must start at the origin, which is point 0, 0, and be a straight line. Right? It can't be, the only way that that thing stays constant is if it's a constant line, right? A constant rate of change. So it needs to go through the origin and be a constant rate of change. If it goes through the origin and wiggled everywhere, right, there's going to be changes happening there.
Origin has an I before the G.
Origin. Yeah. So in a table, it's represented by a constant of proportionality. And we get that constant k by doing the ratio of y to x. Okay? So the constant of proportionality from a table is always y to x. But remember, a table is just a representation of the situation. A drawing of a graph is just a representation, and an equation is just a representation. They're all the same line. Different representations of the same line. So what's going to be really cool here is all we have is the graph. Now, the first thing I do when I get this graph is I make a table, because I love tables. I don't know if you ever met a math teacher before, but usually math teachers love tables. This is not a requirement of this problem, but I just find it beneficial. So I see at 0 pounds of sugar, there's 0 cups. But I see at 4 pounds of sugar, there's 20 cups. 8 pounds of sugar, 40 cups.
Where do we have to do
12 pounds of sugar, 60 cups. So I'm just choosing to do that. Now, it wants me for letter A in this problem to come up with the COP, the constant of proportionality. And how do we get the constant of proportionality? What ratio? What to what?
G to
We just y to x. I think it's easiest from the table, but it's the same. Okay? So it doesn't matter which y to x you choose. I'm rocking a 20 to 4, which gives me a constant of proportionality of 5.
Wait, on the first one it says COP minus 10.
I think it's just like saying it's 10.
Oh, COP 10.
So in this case, I'm saying the constant of proportionality is 5, which, if my equation is y equals the constant of proportionality x, that means my equation for this table and this graph is y equals 5x.
So I have a question.
And here's what this means in context, because this is where it gets really
For
important.
every pound.
That means for every pound of sugar,
There's 5 number of cups. There's 5 cups.
yep, there
Is that
are
like all the
5
pounds?
cups. Which is cool because, like, this is a statement that almost gives, like, situational context, right? All we started with was a graph.
Yeah.
How cool is that, right? Like, in terms of communication, they each exhibit something a little different. Also, what do you think's easier to pull the constant of proportionality from, the table or the graph?
Probably the table.
I think the table, it's right there, y to x,
Why
but
did you write
I had to get the table from the graph, right? It's cool how it's like, it's all just there to make a bigger, clearer picture of everything. That's why we have multiple representations. Okay? Thanks, Mikey. That is an R, A-R-E. There are 5 cups. All right, friends, back to your seats. Eyes up here, mouths closed, please. Let's take a look at these situations. So, for number 3, who can give me a constant of proportionality? Tanyan.
For number 3, 15.
So I'm going to say K equals 15. And how'd you get that?
I did 30 divided by 2.
So you have 0.230. Y to x is 30 over 2.
Check it, I didn't see.
All right. Who's got an equation for me? Nathan.
Y equals 15.
Yep. If y equals kx, then y equals 15x, right? That works for every point on the line forever. All right. And who can put that situation in words for me? Yeah, Lyndon.
For every washing machine, there are 15 clothes.
For every wash machine, there are 15 articles of clothing. Okay.
Does that mean you can just put 15 socks in it?
Sure, 15 socks. I guess 15 coats, 15 socks, same thing, right? So, number 4. Who can give me a constant of proportionality from our table? Caitlin?
4.
We have 4. And how'd you get that? Yep, so if it's 0.520, the y to x ratio is 20 to 5 or 4. I'm going to take this one because it's so hard. Y equals 4x then for our equation with the constant of proportionality. Okay. And then who can put that into words for me? Will.
For every container you have, it can hold 4 liters of water.
Container. You can hold 4 liters of water. Or 2 liters.
Wait, this is
Most of the world. Okay. Will just said, who uses liters? The answer is almost everybody else. All right. Number 5. What is my constant of proportionality, James? 5. How'd you get that?
1 times 5 is 5.
Yeah, so the y to x ratio for 0.15 is 5 to 1. I'm going to take this because it's the hard one. The equation is y equals 5x then because the constant of proportionality x. And then who could put that in the context for us? Mike?
For every day, there are 5 bags sold.
For every day, there
5 bags sold.
are 5 Gucci
You're
bags
obsessed with just
sold.
putting A.
I keep writing A instead of R.
Like put R at least. Like
Okay. So, we got 2 more here. We got those tables to mess with now. Let me get those in the document. And again, these are just y to x straight up. I kind of wish I had context, right? What are we talking about here? Nobody knows. But if I'm finding the constant of proportionality and it's y to x, you can use any point and it works, right? If it's through the origin, you can use any point. So I'm choosing that point. Do you see why? I mean, it's just a little easier, I think. So y to x would give me a constant of proportionality of 3/5. I heard some 0.6s floating around. I'm all right with that. I'm a fraction guy. In the higher levels of math you get, you're going to lean on fractions more and more because they pump out exact answers. Because something like 1/3 is different than 0.33. All right? So keep working on those fractions. And then number 7. Who can tell me how they got there? Joe?
So, I just did from x to y, I did 2 divided by 1 equals 1, but then I felt like I could make that into a whole number instead of it being -2. And the opposite of -2 is 1/2, so it would be y equals 1/2 x.
So the equation is y equals 1/2 x. Yeah, so y to x is 1 to 2. And it doesn't matter where you pick it, right? 1 to 2, 1 to 2, 1, 2, 2.
Oh, shoot. I got
Cool.
this.